right, one thing I forgot to mention with question 5, sorry about that, is this point here, the maximum. It's going to be on the same x-coordinate as the minimum, which is the vertex. But don't forget, y is going to equal 1 over the f of x, so 1 over negative 4 on 3, which here gives us negative 3/4. So the maximum here is at 1 comma negative 3/4. We're going to sketch question 7, and we're going to try and do it methodically. Okay, so we want to know, it's obviously a quadratic, so let's start off by following the normal steps. So concave, there's no negative in front of that x squared, so it's up. Y-intercept, so we let x equal 0, we've got y equals a half, 0 squared plus 1, so it just equals a half. The x-intercept, x equals 0, so y equals 0, sorry, so we've got 0 equals a half, x squared plus 1, times both sides by 2, I get 0 equals x squared plus 1. So negative 1 equals x squared, no solution, no zeros. Ooh, this is going to be interesting. Now let's find the vertex. We've got y equals half x squared plus 0x plus a half. I've just expanded the brackets and I've put in 0x to remind myself, because the x coordinate, so this shouldn't have been y, we've got that. The x coordinate is minus b over 2a, isn't it? So we've got minus 0 over 2 times a half, so it's just 0. So the x coordinate of the vertex is 0, so the y coordinate, you sub 0 in, we've got a half, 0 squared plus 1, it's going to be a half. They've also asked us for the points where y equals 1. So let's figure that out. And I'm also going to do y equals minus 1 if it occurs. Because, I mean, they won't always. You could have a graph where the whole thing turns above y equals minus 1, and I think that's the case. So y equals 1, we've got 1 equals a half x squared plus 1, times both sides by 2, we've got 2 equals x squared plus 1, subtract 1, 1 equals x squared, so x equals 1 and minus 1. Let's try minus 1. We've got minus 1 equals a half x squared plus 1, so minus 2 equals x squared plus 1, so minus 3 equals x squared doesn't exist. Now let's draw this sucker. Nice and big in the middle. Y and x. Start off by putting the points we know in. The y-intercept, half. The x-intercept, no solution. The vertex, well, it's going to turn here. And y equals 1, so x equals 1 and negative 1, so there and there. So this is what that looks like, and that's y equals f of x. What is the minimum value of that? Well, the minimum or the maximum is always going to be the vertex. Like, it's always going to be where a quadratic turns, yeah? So the minimum value, so x equals 0, the minimum is at y equals a half. Question C, they're asking us to sketch y equals 2 on x squared plus 1, which is the same as 1 over a half x squared plus 1, okay? So we'd have no asymptotes. So f of x has no zeros. Has no zeros. 1 on f of x has no vertical asymptotes. Let's see if it has any horizontal ones. Or actually, no, let's just do our normal intercepts. So the y-intercept, x equals 0, so we've got y equals 2 over 0 squared plus 1, so it's 2. Okay, so let's put that in, the point 0, 2. X-intercepts, let's see if it exists. So can we do 0 equals 2 over x squared plus 1? That would mean 0 lots of x squared plus 1 equals 2, so 0 equals 2, no x-intercepts. Rather, we have a horizontal asymptote. Which makes sense, because this is 2 on x squared plus 1, it's not 2 on x squared plus 1 plus 3 or something. So we're going to have a horizontal asymptote along here. And because f of x equals 1 at x equals 1 and x equals minus 1, so will 1 on f of x. So all I'm saying is that the points where y equals 1, f of x equals 1, we're going to go through the same points. And our maximum is going to be at the minimum. Well, it's at, say, the x coordinate of the minimum. In f of x. So that was x equals 0. So here we're going to have y equals 1 on 0 squared, 2 on 0 squared plus 1. So it's just going to be 2. So yeah, we've already graphed it. This is our maximum, yeah? So it's going to kind of come along and then go along and never get there. Come along, go along, never get there. That was question C. Question D asks us to actually explain why there's a horizontal asymptote at the x-axis. So we know, we've already done this, x-axis, y equals 0, 0 equals 2 on x squared plus 1, 0 lots of x squared plus 1 equals 2, 0 equals 2, asymptote. On x-axis. Because 0 is not 2. The maximum value of 2 over... Oh, we've already done this. Let me get a better highlighter that actually highlights. So I accidentally did E there, but it was useful. So the maximum value is 2. You can see it. It goes up to 2 and then comes back down. That's